We're given this recurrence relation. K is a constant. The sequence is periodic of order 3. That means it repeats every 3. And A1 is equal to 2. The first term is 2. Now what we can do is let n equal 1 in this formula to get A2 here is equal to K times A1 plus 2 over A1. So A2 is therefore going to be K times 4, or 4K, over 2, so 2K. And we can keep going. So A3 is then going to be, I just replace n by 2 in the formula, and I get A3 in terms of A2. K times 2K plus 2 over 2K. Going to cancel out these K's. I am assuming that K is non-zero. If it was 0, we would actually get that A2 was 0, and then we'd be dividing by 0. So I feel like the question should have, I suppose it doesn't have to specify it, but I can say it's definitely not 0. And then it's going to be 2K plus 2 over 2, which actually gives me K plus 1. So far we've got 2 followed by 2K followed by K plus 1. Now remember, the sequence is periodic of order 3, which means the next one, whatever it is, should equal 2. But let's work it out in terms of K and then set it equal to 2. So essentially what I'm saying is we can say that A1 is equal to A4, but we've got to find out A4 in terms of K. So A4 is going to be K times K plus 1 plus 2, so that's K plus 3, over K plus 1. It doesn't cancel down nicely this time, but that's okay. It's absolutely fine. So what we can do is use this and say that K times K plus 3 over K plus 1 must equal 2. And therefore K squared plus 3K, I've expanded the bracket, and then I'm going to times by the K plus 1 is 2K plus 2, which means that K squared plus K minus 2 is 0. And that was what we're asked to find. In part B, we're asked to explain why for this sequence k is not equal to 1, which in fact is a solution to the quadratic. We'll see this in a minute. So what happens if k is 1? Then the sequence becomes 2 followed by 2 followed by 2. It's actually 2 forever. And this is actually periodic of order 1. Not 3. So although it satisfies the equation a1 equals a4, that doesn't necessarily mean it's periodic of order 3. It's kind of like a necessary condition, but not sufficient, actually. And that's all we need to say. We just need to explain, although it solves the quadratic, it's not the sequence we're interested in because it has to repeat every 3 rather than every 1. Then finally, we're asked to find the value of the summation of the first 80 terms of the sequence. So first up, I'm going to solve my quadratic. K plus 2 times k minus 1 is going to equal 0. So k is minus 2 or 1, but we rejected that one. Kind of part B helped us realize why we needed to reject it, because we don't get a sequence of order 3. Now what happens if I go with minus 2? So I'm going to get 2 as my first term, then minus 4, then minus 2 plus 1 is minus 1, and then when I put it back in, it's going to be 2 again. I mean, it must be because of how we constructed the quadratic. You could, of course, put it into this term. Then it will be minus 2 times 1 over minus 1, which will give 2. So this works, and it's going to go on, it's going to repeat like that forever. So it is periodic, order 3. Okay, so now we want to sum up the first 80 terms. Well, let's see how many 3's go into 80. You can do it on your calculator, of course, but we're going to get 2, 26, remainder 2. So I'm going to get 26 lots of the triples, 2 plus minus 4 plus minus 1. Maybe I'll just say 2 minus 4 minus 1. So that will give me 78 terms. For example, if I was doing the first 3 terms, I would just add them up. If I was doing the 6 terms, I would just add them up once and times by 2. That's what I'm doing here. I'm going to be, to add up the first 78 terms, I just do 2 minus 4 minus 1 and times by 26. That's just going to leave me then back to the beginning. I just need to add an extra 2 and a minus 4. So it will be 26, and that's a minus 5. 26 times minus 3, minus 2, which becomes minus 80. So this is not like a geometric series or arithmetic series. You know, this is very different. It's a recurrence relation. They just made it so it repeats every 3 times. It's a different way to sum it. You can't just stick it in your calculator. You have to realize something along these lines. You know, you could also add up the first 27 terms and then just take away the last minus 1, but I think this way is good. So final answer is minus 80. Well done on this question.